Hey, it's Tabuli, recording for the Map Room, where my friend Tristan and I talk about Atlas Altera, a creative project where we use a familiar but different map of the world to tell the story of us, humanity. Today we're starting off the first part of a new series of videos to go with a recent map graphic I published on ancestral lineages and admixture profiles for Altera. The hope for today is to set some informed foundations for learning about the theme, while also eliciting some curiosity for real-world ancestral studies and genetic clusters. I hope you enjoy, and do subscribe if you want to stay in the loop.
Back in the map room.
All right.
For another talk.
What are we talking about today?
So today, we're talking about the other graph you have on your core graphical depictions map.
Well, it's not a graph, right?
Or
I guess
it's a... What would you describe it as?
Decorative map art. I mean, it is like a chart, I guess.
Yes. Okay. So what you have here in this graph, or whatever you want to call it, is a set of points, which are colored a little different.
So this one is lineages in our admixtures. So I wanted to talk about race without talking about race. That's the gist. I wanted to, because us humans, I'm not sure if it's just culturally derived from Europeans or, from colonialism, but I think a lot of people still, they can't imagine another world, another place, without picturing the skin deep look of those people. What do they look like, right? And so it's a very shallow way of looking at the world, but still, like, since, antiquity, people have been describing people in that way. Like, they've been using skin color, features like nose, ears, and, it's gone real downhill. We don't need to talk about the 20th century, but it's not that we still need to be talking about this, not because it's important, but it's just a common theme that people seem to have a really hard time talking about nowadays, but they're all thinking it. Mm-hmm. And really importantly, people in the medical sciences and, biology are doing a lot of work now, and sometimes not really properly informed with geography. And so they're doing all this work, whereas like people in the social sciences have seen it as taboo. So I just thought, well, I might as well kind of look into the research and, figure things out kind of scientifically, while also staying true to the goal of my project. So it's called Lineages in our Admixtures. The lineage refers to the fact that we have ancestral genetics. We have in our genetics traces of our ancestries, and there are no such thing as races. But if you were able to sample perfectly the human population, out of 1 billion, you sampled 1 million people, okay? And you did it equally around the world. You were able to find like representatives from all around the world, 1 million. Then you could divide them into clusters of similar genetic kind of groupings that aren't different enough to make us different species, but are different enough to show phenotypical variations, and sometimes even extreme things like bigger spleens for underwater diving, like the Bajau, or like better blood circulation, like the Tibetan Plateau, where the babies come out with a higher chance of survival in the thin air. So there are those kind of adaptations, but they're like minuscule. But anyways, the point is, if you wanted to arbitrarily, and arbitrary is the key word here, if you wanted to arbitrarily divide the world, you can, based on shared genetics. And the scientific community, especially in biology, and medical sciences, have been very interested in this. Sometimes it's very good, like they're like, maybe because certain populations have different genetic considerations for medicine, like you need to understand like dosage. But other times it's trying to just like prove migration, and that's for like anthropology and archaeology. And sometimes it's a little flawed because it's like you're trying to prove something that you already want to prove. But anyways, the research is fraught with this tension, but it's still very interesting. Mm-hmm. So lineage suggests that we have in ourselves markers of these ancestral. Lineage suggests that we have these ancestries, and you can show by arbitrarily grouping the people based on genetic into genetic clusters that you can show lineages to certain clusters in a human population. So what I mean by that is that, like, let's say people in North Africa, you can show that they have shared lineages to peoples in Europe, to West Asia, and to a degree Sub-Saharan Africa. And those, like, using those geographic proxies, you might use those to term clusters, ancestral clusters. So if I wanted to divide that million people into 7 or 5 clusters, actually commonsensically, you would actually see the world divided in how an American white person would see race. You would have black people, okay, or sub-Saharan African people. You would have what are called white people, so Europeans, even North Africans, as well as West Asians. You would have Indians, Australian Aboriginals, and the 5th one would be East Asia and the Americas. Then you go to 7, and then things start splitting off. Then you go to 10 clusters, and there's more variation.
Wait, okay, so hold on. How do you create these clusters? So what is the genetic marker which distinguishes different populations?
Okay, so the numbers are arbitrary.
Okay.
But the genetic distinction is to show, like, it's very interesting. They use a computer algorithm, and basically you look at the genetic variation in a single person, then you input their variations with everyone around in the samples, and then you find you do kind of like a data analysis where you find closest clusters where, like, this person's variations are closer together than that person's variations. And so then you can say, I want the sample to be divided into 5 or 7, and it'll kind of, like, you know, those kind of graphs, it'll try to put those into similarity clusters. That's how they do it. I don't know too much about that. I just know, like, it's a mathematical modeling, and the flaw actually comes from your input, from how you're doing your sampling. So there's a famous K equals 15. So he tried to divide the world into 15, a K equals 15 sample. That was one of the largest samples ever done, and that was probably only 1,000 people. And this guy named Rosenberg, didn't do it very well because he kind of missed the diversity in sub-Saharan Africa. Like, we know for sure that sub-Saharan Africa has the most diversity in the human population, but he got very little samples from there. He got a lot of samples from Europe and North Africa and West Asia.
Classic
and
issue, right?
Yeah, classic issue. And for Australia and Papua and whatever, like, he didn't get any Australian. He got like 2 people, one in Australia and one in Papua, a few in, like, you know, the Solomon Islands. So what we now know is actually that Australia, Solomon Islands, Papua, these peoples are actually descendants from some of the earliest migrants out of Africa, which means that Australians, Papuans, the Solomon Islands might even be divided into 3 different distinct groups. They have more variation than, let's say, Europeans, West Asians, and North Africans. So it was flawed to begin with. The point is, though, I qualitatively, using my understanding of geography and human migration, I use that to look into regional sampling. So there are people who have done samples for Africa, people who've done samplings for East Asia, people who've done samplings for Papua New Guinea and the Solomon Islands. And I've looked at how they compare their work to Rosenberg, and I was able to devise my own clusters.
Right. And so the reason why you chose 20 is to be able to show more diversity within subregions.
Yeah, I wanted to really show difference, but also to kind of flip the idea of what racial descent means, because a lot of people think that they are one thing, but they're not. So, for example, you know, people, let's say in Turkey, think that they're, like, very different from Greeks, but, you know, they might actually they share similar ancestral lineages. And people who are from the Siberian steppe, like the Hungarians, they're actually mostly just Slavic, right? Like, there's that kind of ironies there.
Okay, so let's dive into the different points themselves.
Yeah.
So you've come up with, like, a color scheme here.
Yeah. My color scheme is very simple. It kind of maps the chorographical depictions color scheme map. So the blue represents Africa. The kind of green represents Europea, what I call. And then the turquoise is, like, in between transition zone. So the Mediterranean and what I call Erythrid, they're kind of a transition zone. So that's like the Horn of Africa and Red Sea for Erythrid. And Mediterranean is actually, like, people like Sicilians, North Africans, like people from Southern Europe and North Africa actually have more similarities. Purple is Temeria, right? That's like Australia. And you can see actually there's quite a bit of diversity here for that region. And that was what I was getting at, where because they're earlier migrations, that, like, there's actually, you need to put more of them on. If you want to put all this diversity in Eurasia, then you need to actually address that. The one thing where I did it completely contrary to science is I put 3 groups of the Americas at this division, like 24.
24 clusters.
Yeah, the 24 clusters. Really, probably only one of them would show up, maybe 2.
Okay.
So I decided to do 3 plus Arctid, which would be the Inuit, which are kind of already, we know, is like they're a late migration. They come from Siberia, late migration into the Arctic in the Americas. So really there's 4 here that represent the Americas when there really should be just 2 or maybe 1, because in the grand scheme of human migration, they're quite late, and they branched off of East Asia quite late. But really, if you look at just the Americas, like when they do this kind of K equals 5, K equals 7 or whatever, there's diversities within that. And that suggests really interesting migration hypotheses, or they lend themselves to very interesting migration hypotheses, like how humans followed glaciers, or humans followed the coast, or how humans first thrived in the Amazon. So there's this one, like Meridid. This would probably be the most divergent of all of the Americas lineages. The people in Brazil, in the Amazon, they have the most genetic difference and divergence. Whereas like people from like Arizona to the Andes probably share a similar migration history, and then people in like the woodlands of America and the taiga, they're more like similar. Anyway, so one last thing about this. There's a really interesting note here about purity. The only people who can probably claim themselves to be pure are the Australian Aboriginals. They have been isolated for such a long time that there's not a lot of impact from neighboring clusters. So the samples that you take from Australian Aboriginals should suggest that they have very little contributions from neighboring groups. Whereas like if you take a genetic sample of, say, someone from like Sweden, who people might say are like very pure, but more Aryan, like Hitler. But even today, Europeans kind of subconsciously still believe that people in Scandinavia are some sense of pureness. Okay, they really aren't. They have genetic contributions from Finno-Ugric and other kind of pre-Proto-Indo-European peoples, right? Interestingly, the Bosnians and the Swedes have a substratum of genetics that suggests that they preserve actually pre-Indo-European peoples. European genetics has been studied the most, so we don't need to go there. But it's just there's a lot of these ironies that are present here.
Okay, so tell me if I got this right. So you started with the genetic studies that scientists have been working on for a long time.
Yeah.
Usually the way they divide it is in 5 to 7 clusters.
Yeah.
Which mirror like the classic division of races.
Yeah, Mongoloid.
Yeah, all that.
Yeah.
What you did though is, so rather than dividing it in 5 or 7 clusters, you divided it in 24 clusters.
Yeah.
Which allowed you to have more representation.
Yeah.
And the way
But it's actually more factual too.
And more factual as well.
Because people over fetishize the differences between North Africans and West Asians and Europeans, and they completely miss the fact that there's more genetic diversity and divergence in Sub-Saharan Africa and Oceania.
Right, which this represents in the blue and the purple.
Yeah. Yeah, I did come up with these names. So a lot of times, some of the names were, for example, like Khoisan people or Bush people, they use like, they use Paleo-African. There's a literal meaning of that, but Paleo for a lot of people in the modern day world also has connotations of archaic, like out of date. For most of them, I tried to use Geographic Association to do the naming, and the Geographic Associations are associated with Altera, so it's a little confusing for some people sometimes. So like Formosid here is not like Taiwan Formosa. Formosid here is like Formosa on my map, which is Palawan Island. And the Formosid there actually just represents it represents the main Negrito population. So Negrito is still commonly used, but it's basically the Aboriginal peoples that exist from the Andaman Islands to the Philippines. And it's interesting, they actually suggest that even among them, there's like a huge genetic diversity, but I decided to kind of limit that to just using one to group it.
Okay, so for example, if we compare this to the political maps and the political borders that you've come up, let's take France, for example.
Yeah.
Where would France be situated here?
Right. So again, like I did this because I was interested in, like classic ideas of, human difference, but we got to be careful because like there's this guy called Masaman, on YouTube, and he kind of like conflates ethno-linguistic groups with race, intentionally sometimes, and he also has a hard time getting at how we are layers of genetics. Okay, so when he does his mapping, like for example, the reason why I did these stars is because it would be flawed to map the world on racial lines. So France, for example, you're asking France. France isn't just Europid. It's like that's why I said lineages in our admixtures. Admixtures suggest that all of us have layers that show connection and contribution from these different themed clusters. Like the idea of a cluster is already flawed because like we're just trying to find similarities in the data. But if we were to find similarities in these datas, we're saying that from this cluster of similarities at one point in time, there was an injection into this area. And then from this cluster, there was also an injection. I use in one of my in my fact book, I use a column of makeup, this category called makeup, and I use the words conjoined, converged, and conformed. So makeup is a way of describing what a lot of people want to know. What a lot of like, let's say Europeans want to know is like, what did people look like? So conformed means that they've cemented and look the same, but it doesn't mean that they have the same, like 100% one lineage. They just have been mixing for so long. So the function here is time. So they've been mixing for so long that they look uniform. Whereas if you change that time variable to very recent, you will have conjoined populations. When I say conjoined, I usually mean just like multiracial is like what the Americans might say, or multicultural. So in America, we see in America they use the word race, to differentiate black and white people, but it's a social construct, right? Race is a social construct. So by saying multiracial, that's just what I'm referring to. But what a conjoined population is a population where there are people living side by side, either by force or not, and either they are forcibly separated or not, but they're sharing the same territory. So in apartheid South Africa, for example, it's a conjoined population. Geographers should be looking at this kind of like sober-mindedly and saying the demographic makeup of this area consists of these peoples, and they're conjoined. They live side by side. Whether or not they're going to mix in the next 20 years is besides the point, because when you have populations living side by side, they're gonna find a way to mix. Mm-hmm. So they're just in the early stage. Like no matter how hard you try to keep populations apart, when they're next door to each other, they're gonna start drifting into one another. So America right now is just like, despite like maybe like a subconscious or like obvious racial prejudices, in 200 years they're gonna blend more. So there's gonna be a browner America, and National Geographic, whatever, they've already done, like it's already been a cliche thing to run stories on this. It's just natural that like populations will mix, and so there's the middle category, which is converged, which is probably what the Latin American and French term mestizo métis best describes, which is that they can still see the visible evidence of two populations mixing. And like those two populations might still exist in that group, in that territory, but there's also the one that's the offspring of those two populations, mm-hmm. the mixed one.
I see.
But everyone, like in every country, so France, you can find different genetic clusters, but they're just at different times of mixing, different points of mixing. That's the point here.
Mm-hmm. So, I mean, in the case of the United States, Canada, and France,
yeah.
The colonial history obviously contributes to the fact that nowadays you have much more of multiculturalism in these countries.
Yeah.
So that would be in our real world. What about in your world?
So in my world, neoliberalism doesn't happen to such an extent. Like we might be just at the cusp of it.
So you have less conjoined.
No, there are so America is still conjoined in the sense that slavery happened, right? But first of all, let's talk about multiculturalism today. Most countries, the multiculturalism is actually not to the degree, the drasticness that conservatives would like social conservatives would like to point out. If you look at it, a country where it's 90% white, but it's multicultural, like you have very multicultural Vancouver, very multicultural Toronto. Like Canada not be 90%, it might be like 80 something, but where the majority is still white to that degree, like the multiculturalism will be so insignificant that population-wise, I wouldn't even be able to categorize them. So what I mean is I wouldn't be able to put Sarid among the ancestral clusters for Canada. Okay, our modern world, Canada. For America, there's enough African Americans that you would put, like the West African one. So you would put Ghanid, and then you would put Europid. You might put Mediterranean because Italian migration. But the point is, we only in the last 30 years have we had this kind of multiculturalism, and it hasn't made that big of an impact yet, despite the fact that people are alarmed, like conservatives are alarmed. It's actually a small drop in the bucket. So like you have to understand that the demographic shift of like the 1600s and 1700s was way more drastic. Anyway, so the point is, if I were to write like Canada's conjoined or United States is conjoined, I would write like the 25% or the 50% of the population kind of categories. I wouldn't be able to put in all these other smaller ones. And multiculturalism does exist in this world. Like liberalism is still in existence, but neoliberal economics, the logic of neoliberal economics of bringing migrants over to work in your factories, doesn't take place in most Western countries. So, but refugees and like political migrants, they still happen, but there's actually very few multicultural, ideologically multicultural countries. The United States is still one of them, but a lot of these European countries are not, because they're not, because the neoliberal shift isn't that strong there. There's a different kind of political tension in Europe. But that's not to say that I don't believe in multiculturalism, right? Like the country that I have the most affinity towards in my world, California, is like hyper pluralistic. Anyway, yeah.
Okay, so you've come up with these 24 clusters, which I guess you can divide the human population into.
Yeah.
But obviously, because of the admixture of our lineages, each country has
more than
a
one
different makeup
Yeah.
of these different clusters.
A different combination, exactly.
Okay.
Now, there will be an oddity. Some people will say like, oh, Britain, it looks like there's just Europid. Okay, I've just listed Europid for Britain. And that's just because that the way these clusters work, like Britain is a melting pot of various Europid like subgroups. But Europid is already a catch-all thing for a lot of European diversity. Now, as you go more south in Europe, like France, for example, the contribution of the next kind of major geographic population kind of significance, the Mediterranean, that goes on to it. So that makes that manifests in the genetics. Like I would need to break up the world into more clusters to show that, let's say, Britain has a lot more than just this one category. Anyway, the point is that most countries will have multiple like combinations of these clusters, and then the makeup category will show at what stage of kind of like mixing there is.
Yeah, that's actually really neat.
Yeah,
because it allows you to talk about race without talking about race.
Yeah.
Falling into the traps of having these like 5 or 7 categories, which
these pseudoscience
omit a lot of greater divergence within a region which is generalized.
Yeah,
that's neat. Because it is a really complex topic, genetics.
Yeah,
and to actually understand how these clusters work, or even why they're divided in 5 or 7. Demands a little, study.
Yeah. One thing to remember is that the way they look at these genetic clusters is that they showcase them. They'll say like, from the population that they drew from, maybe like French people, they'll put a long kind of bar graph to represent the French people, and they'll show the percentage of similarity they have with the other categories. So a French person's bar graph will have like maybe 50% of it one color, and it'll like show like Europid, and it might show like 30% Mediterranean, and it might show like 10% this, 10% this. I'm just making this up. I don't have it in front of me. But almost all of these bar graphs for these populations show hyper variation. There will be a majority, let's say 50%, 40%, sometimes it'll be 35%. So I try to do the 4 most biggest contributing ancestral clusters in my fact book, in my Excel thing. Anyway, so when I was doing this project, I started like becoming aware of this, and I was like, okay, so there's like Pygmy peoples, okay, like there's Twa people, you might call them Twa, but like some people are surprised to know that there are people in this world who, not due to malnutrition, but just genetics, are a lot shorter than the majority of the people. And even if you give them like a similar diet as like the people next door, they won't grow to the same height on average. So these Twa peoples and the Khoisan people, or the bush people in sub-Saharan in like South Africa, okay, in Tanzania, it's very hard for me to get a state where they are, the main like the ancestral cluster. That's the main one that shows up. The Formosid, I was able to figure out a couple of like island states southeast of the modern day Philippines that I could invent the history where Austronesian settlement was like very minor, and they really are the main contributors. But yeah, I just wanted to try to like tinker around with this variable for diversity as well.
I really like how you call them constellations, clusters.
Yeah.
It's a cool way of putting it, because they do actually look like star constellations.
Well, the way I did it here.
Yeah.
And it's implied that we see what we want to see. So people will see similarities, like, like if you go to like Peru or like China, they have different names and different constellations. They have different names for constellations, and they might have completely different configurations. They're like, no, that star belongs in this constellation. That star belongs in that constellation. So here, this whole thing is like, different people from different parts of the world will draw some groupings out of these the way they want to. I just use geography to kind of do a basic coding, the color coding.
Yeah, I'm interested to see in the future how these clusters plug into country level.
Okay, that's a wrap.
I think that's a wrap.